So Google Sheets can do this kind of stuff as well. That is, find areas underneath the standard normal curve. And it might make it a little bit more convenient. Kind of depends on how comfortable you are with Google Sheets. I would count on knowing how to do this with the tables. But the command that you want for the area in the tail, area to the left of something in the tail underneath the normal curve, is this. Norm dist, you might see a little pattern here, of x, and then the mean, and then the standard deviation. And then this next part set to true. That gives it what's called the cumulative density, as opposed to just the probability density. You're going to want the cumulative density. So this is going to be the area underneath the normal curve to the left of x. So the area underneath the normal curve to the left of x, the standard normal curve. It's a standard normal curve assuming you set mu equal to 0 and standard deviation equal to 1. So what you'll get is this value, the area to the left of x. So one of the ones that we did earlier was to try and find the area to the left of 1.96 underneath the standard normal curve. So to get that here, I would type in norm dist of 1.96. Standard normal curve has a mean of 0 and a standard deviation of 1, and that would be a true. Let's see how that works. So give you a second to copy that down. Normal distribution of 1.96, comma 0, comma 1, comma true. And let's put that into our sheets. So equals norm dist 1.96, comma 0, comma 1, comma true. So we get a few more digits than we did from the table in the back of the book. You should be getting about the same answer that we got with the back of the book, 0.97500. Of course, the book's going to round it to the nearest 10,000th place. What about a problem like number 28, where we wanted to find the area between two of these things? So let me take a look back here quick at problem 28. 28 was to try and find the area between negative 1.93 is less than z is less than negative 0.45. The way we did it then and the way we're going to do it now is by subtracting. Find the area to the left of negative 0.45 and subtract off the area to the left of negative 1.93. I'm not sure if you want to do this in one command or two. Let's type that in Google Sheets. So that's going to equal, let's try and find the area to the left of negative 0.45 first. Norm dist of negative 0.45, comma 0, comma 1, comma true. Help if I spell that right. So that's the area to the left of negative 0.45. Are you getting something different? Let's try to find the area to the left of negative 1.93. And I guess I like the idea of doing this as two separate commands. That way, if you got something that just doesn't look right, you'll be able to trace the error a little bit easier. So negative 1.93, comma 0, comma 1. And then as always, true. But we want the difference of those two. So I'll do equals. Click the first cell, minus, and click the second cell, and there you go. 2.996 roughly. Okay. How are those looking with Google Sheets so far? What do you like better, the table or Google Sheets? Google Sheets. Mostly Google Sheets, and then a lot of abstentions, and some people like tapping their watch like, isn't it 1 o'clock yet? All right. Let's try the other thing, which is, what's that? No. You sure? Is there a typo here? Okay. Suppose you wanted to find the z value that corresponds to the area. It is working this the other direction. We can do that as well. So that's going to be the norm inverse command. Let's see if I... so let's go back here to our notes. So to find the area, to find a specific area to the left, we'll use this command. Norm inverse of whatever area you want to the left, area to the left, and then the mean and standard deviation. Mean and standard deviation. So we did a couple problems like this. The most recent one was find the point with 77% of the area in the left tail. So that was one of my examples, or actually 78% of the area in the left tail. So z sub 0.22, that means 22% of the area in the right tail. 22% in the right tail. But we want the area in the left tail. So what area are we going to have in the left tail? Well, that's going to leave 78% of the area in the left tail. So to find this one, then what you're going to do is use the normal inverse with 0.78. And then again, the mean and standard deviation. So it equals norm inverse of 0.78, mean of 0, standard deviation of 1. So let's try that. Equals norm inverse 0.78, comma 0, comma 1. So you get about 0.77. Z-scores are always rounded to the nearest hundredth, because that's where our tables go. So in this case, Google Sheets is giving us a little bit more, so we're getting about 0.77, which is the answer we got earlier. All right. So, I don't know, looks to me more convenient. The only thing that you have to be careful of is that the normal inverse command is going to give you the area in the left tail. Now sometimes your problems are going to be talking about area in the right tail, so you have to convert it to something that's in the left tail.